Hi, my name is Hillary Yamtich with the Better Lesson Project, and I wanted to sort of defend this lesson on inequalities and absolute values, which seems really simple, and I imagine if you're teaching year 4, you think, okay, this is not year 4, this is like 7th grade. But I really want to make sure that all kind of misconceptions or confusion about just the concept of inequality are cleared up, or at least addressed, before we get into kind of the really complicated piecewise function. So if students don't understand inequalities on a number line, piecewise functions are not going to be accessible to them. And I know that one lesson is not enough to go from 0 to full understanding, but it is enough to get the conversation going and make sure that students are sort of thinking about inequalities and what they mean and how to represent them in different ways. So if you find the lesson to be incredibly easy for some students, you can use the absolute value inequality kind of extension as a challenge, or they can start to try to figure out, use the warm-up examples about piecewise functions to try to sort of preview all of the ideas of the unit on their own, if that's the case. But I think the multiple representations tends to be challenging enough for most students who haven't been thinking about it for a while, especially trying to convert the real-world examples into a number line and to a symbol and to a verbal description. So the big idea is just these inequalities, they're kind of actually all around us. This actually is something that happens all the time. You need to arrive before 8 a.m. in order to get the discount. You must have at least a 75, no more than this many. So the whole point is to kind of get those words out there and try to really be specific and precise about their meaning in a lot of different ways. So this is something where students can hopefully get started on it. You can give them the organizers and give them the questions and just say, figure it out. And then they're going to really start struggling and asking questions about, okay, what do the symbols mean again? And which is what? And there's often more than one way to represent this. So like we could say x is less than or equal to 8, or 8 is greater than or equal to x. And so this is a time to really have those conversations about precision. Are both of those correct? Does it matter? So I would say a big goal of this investigation is for students to be as precise as they possibly can in showing this different ways. Don't tell them anything, but when they say, wait, what does an open dot or a closed dot mean? Ask them, what do you think it might mean? Why do you think they might have created that different notation? What would it be used for? Hopefully for them to be able to sort of think about, okay, what is a shaded dot means it's included, whereas an open dot means it's not included. Even if they've learned it before, the more they can kind of re-figure it out on their own without you telling them, the more ownership they'll have over it when these concepts come up throughout the unit when we're dealing with piecewise functions.